All right, the purpose of this video is to go over AP Practice Problem 11. It's another problem that involves concepts from hypothesis testing. And in this case, we'll go over how to get all the answers and what the AP is looking for concept-wise, each of the points. And it's good to know what the problem's about. Since you probably already did it, I'll just give you a refresher. It's about a city, and there's this physical fitness program that they're thinking about funding. There's a report that says less than 35% of the adult residents are able to pass a certain physical fitness test, and if this is true, they should have more of these fitness programs and they should fund them. But as usual, there's budget constraints and they're skeptical of the report. So basically, they're thinking about funding these extra programs, but they're only going to do it if this report is true and it's worth their time and money. If basically they find out that this report isn't true, because of the budget constraints, they might skip it and put the money to better use. All right. So in order to test whether their city is physically fit or not, they're going to use the standard of, can 35% pass this test, or is it true that less can do it? So they collect data from 185 residents, and they set up these hypotheses, and they are going to use a cutoff level, the standard cutoff level of 0.05. So basically, their null hypothesis is going to be the normal state of affairs, or basically what would the null condition, something they wouldn't act on. Well, basically, we'll assume that people do make the 35%. Now, technically, even if they were higher than this, we'd be okay with it. We'll just say, hey, the true population is at 35%. Our alternative is they're not at 35%. So basically, if this happens, we're not going to bother with we're not going to think this report's true, and we're not going to fund these things, or we're unlikely to do so. If we find out this isn't the case and it really is bad, it's going to be more convincing that, hey, maybe we do need to do some physical fitness stuff to get people up to the level where we think they should be. All right. So, and they define P. It's the proportion of people who can pass the test. So part A asks us to describe, as has been before, what's a type 2 error in the context of the study and what's a consequence of the type 2 error. If you know what type 2 error is, it's not rejecting the null when we should. So basically, it would be we should reject this number, but we don't. We basically go, okay, we're all right with this. What would that mean in context? Well, they're deciding whether they're going to fund these physical fitness programs, I should say. So basically, if they should reject this and don't, they're not likely to fund those programs. And if they're not likely to fund those programs, then people are going to stay. We were thinking they're physically fit enough, but they're not, and they're not going to gain physical fitness, and they're going to stay. The rate's going to stay below the level that they want. All right. So that's basically what I said. What would the type 2 error be? It would be failing to reject the null hypothesis. That 0.35 is the true number when we should. So we think we sort of go along with the 0.35, and we shouldn't. And what would a consequence be? Well, one result would be the program, those physical fitness programs would not get funded, and it could potentially lead to a lesser proportion of the population being physically fit, which is what they didn't want, but that might be a consequence of it. All right. So that's an overview of A. Part B says that they're going to get 185 volunteers. Now, I know volunteers right off the bat, that's bad, right? However, let's just go with it because they get the volunteers, 77 out of 185 pass, and the p-value for the test. So they go through, do the test, and the p-value comes out really high, 0.97 for the hypothesis stated above. So this is the key thing. They say, if it was reasonable to conduct the test. So we're going to assume that, I know they're volunteers and they shouldn't have picked them that way, but let's assume that it was okay to do that, because that's what we're saying. Let's assume it's reasonable to conduct the test. So assuming this test was okay and that these people are represented the population, what does the p-value of 0.97 lead us to conclude? Well, remember the cutoff is 0.05. 0.97 is really, 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 really high. It's really, really, really consistent with the null. It means that we're quite convinced that 35 is true. So what would we do with such a high p-value? We would fail to reject that null. And what would that mean? Basically, this would give strong evidence that the proportion of residents who can pass the test is not less than 35, or essentially is 35 or better, I guess, or is it at least 35? It's at that threshold. All right. So these people, this sample, if it's okay to do this high p-value, basically, don't say you accept the null, but basically we're not questioning the null. The null looks reasonable, that it's very possible 35% of the people are physically fit. All right. Basically, we're not going with that alternative. We're not worried about being less than this under the scenario. Okay. So that's what you need to do. You need to state what does it make you do about the null, and what is the consequence of it. The last part. Well, describe the primary flaw in the study, which we already kind of mentioned. Well, they picked volunteers. But we have to be explicit about why it's a concern. The key things for this, we want to mention, the key things to mention, they were volunteers. They weren't randomly selected like they should have been. They just let volunteers come in. What's the problem with volunteers, though? Volunteers themselves, like we learn in class, someone said, well, what's wrong with picking volunteers? Well, what would you say? The problem is the volunteers will probably consist of more physically fit people, since they would be more willing to take the test because they would be successful at it, right? If you're very weak or overweight or out of shape or whatever you are, you probably don't want to come in, take a physical fitness test, and have someone tell you that you're not physically fit, right? So someone who's lethargic, I guess, is less likely to want to do this. And somebody who is physically fit wants to come in and be like, oh, your test? Well, let me show you, and all that jazz or whatever. So our problem with volunteers is we're more likely to get stronger people, and we're trying to test if the overall population's weak. Another problem that you should really mention that, I don't know if I have, maybe implied in this, but one of the major problems, why is this a problem? Like, why is it getting these stronger people coming in? Why is that troublesome? Because it's overrepresenting them in the population. We want to use the sample to know, well, what percentage of people, are not physically fit. And if our sample has a higher proportion of physically fit people in it than the population has, then we're getting a biased sample, right? So the other thing that underlies this is, why are the volunteers a problem? They overrepresent the strong people and don't give us a true view of what the city looks like. That's why a random selection would be way better, because we'd be more likely to get a sample that was very close to the population, as opposed to getting all the strong people to come in and then say the city is weaker than they should be in aggregate overall. Well, these strong people came in and like I said, like up here, we saw the strong people make us think, oh, well, the city itself is physically fit. All right. So let's look at the scoring. Part A, which is about the type 2 error. You need two things. You need to describe the error in context and describe a consequence. So some of the consequences are that they won't fund the programs. There'll be a lack of fitness among the residents. I believe those are probably the only two things, but something along those lines, right? So you have to describe what it is to be a type 2 error and what's the problem if they make it. E gets you both. If you only do one of them, you get a P, and then otherwise you get an I, and when I think it's clear. Part B about the 0.97 p-value to the test that they do. You have to basically think of this as the end of a hypothesis test. There's a large p-value. You have to mention that the p-value is over the cutoff. It's actually really large. It's, 0.97 is huge compared to 0.05, right? It's almost 1. So, when it comes to probabilities, it's almost certain, that kind of thing. So you have to mention it's a large p-value. You have to make the correct conclusion that you're going to fail to reject the null, right? And then put it into context. So the context would be, well, the proportion of residents who can pass the test, or refers to funding, right? So you have to mention something about, well, it seems like that 35% threshold is met, and that the people are fit, or that, because all these people are fit, we're probably not going to fund these things because we don't need to, because it looks like the city's fit according to what they found. All right. So you need basically those three parts of any conclusion, the p-value, the conclusion to reject or fail to reject, and the context. Part C, you need to mention that they were non-random and or volunteers. I think I actually said both, but saying volunteers would be perfectly fine. You have to mention they're volunteers, so that's problem number one. You have to describe how a volunteer sample would be different from a random sample. So basically saying that the volunteers are going to be stronger on average because they're going to be more likely to want to take the test, and somehow infer in some way that the reason that's bad is because our sample will overestimate a certain group of the population. Basically, it will be a biased sample. The sample will not match the population, and that's why it's bad, right? So usually a reasonable explanation has these components hidden in it, but they need to be there somewhat. You need to say it's volunteers. Why the volunteers would be more likely to, why would they be overrepresented? They're more likely to do the test. And then why is that a problem? Well, because they're overrepresenting and we're not getting a good picture of the city. All right. Somehow all those things being hit is an E, 2 out of 3 of them being hit as a P, and I otherwise. And once again, this is one of those 3-part ones. So the 3-part ones go in right on here because it comes up so often. So here's another sheet. Once again, 3 E's is a 4, 2 E's and a P is a 3, 2 errors, which is all these combinations, is a 2, and then either 1 essentially correct or 2 partially correct gets you 1. It's a 0 otherwise. All right. So that was AP problem 11 about the city fitness. Once again, has a lot of good concepts in it about hypothesis testing. All right. Next up will be practice problem 12 if you'd like to see it.